Good morning to everyone. All of you can able to hear my voice?
Yes, sir. Good
Yes,
morning.
sir. Good morning. Yes, sir.
Okay, all of you can able to view the whiteboard?
Yes, sir.
Okay, okay. And today next physical lesson on C parallel out. Parallel out. So what is the meaning of serial in and serial in and to the after storing the data in the flip-up, what happen? Parallel, it going to produce the output. That is contested parallel out shift register. Okay. Okay. Serial in, parallel out, shift register. Shift register. Okay. When I'm going to take a 4-bit. So, so what is the implementation of the register? So 4-bit register in the sense internally they are associated with 4 flip flops. 4 flip. Okay. Already you know that in order to operate the flip flop, it's needed clock pulse. It may be either whatever it may be, it's going to operate. Okay, now in this instant, what happened? I'm going to take negative clock, negative any one of the clock, either positive or negative. So even all the cases, what happened? It operates smooth manner. Okay, the clock is not a problem. Okay, so, and then each the user and then each produced output D2. This is a D1, this is a Q1, this is a D0, this is a Q0. Okay. So next, okay, this is treated as a and as a LSB. Each one of them is output. Okay. Here, what is the concept? All the flip top it accepts the data in serial order, and then it going to produce the output in parallel order. Okay. So here, where we are going to okay accept the data. After that, what happen? We are as in serial order. What happen? We are going to shifting the data one by one. Once store the data in the block, in parallel we will take the output. Okay. So suppose, for example, store the zero information, then it store the data in the flip flop. That movement itself, I can get serial in and parallel out. So in this moment, whenever the data is available in this moment itself, okay, I can get the data. Okay, I can get the data. Okay, when the data is that moment it I can get the data. That is called as the serial in and serial out. Sorry, serial in and parallel out. Okay. Okay. Are you understand what I am trying to say there? Okay. Now I'm going to tell. Okay. Uh, when the data is available in the flip flop, when the data is available in the flip flop, when the data is available or stored, data is stored in the flip flop. The data is stored in the flip flop, stored in the flip flop. Okay, that movement itself, that movement itself. Okay, take it out, data, take it out parallel. Okay, okay, there is a functionality of serial and parallel. So now I'm going to demonstrate how it going to. I will show it. It is okay for you? Do you have any queries in the logic diagram?
No, sir.
Okay. Okay. And these are the output. So how many number of outputs are there? Q3, Q2, Q1, Q0. Okay, Q3, Q2, Q1, Q0. Okay. So, so what is the status of flip flop? Already I said each flip flop the reset pin, and I just stated that. So every flip flop what happened, it associated with the reset pin. So before initiate the transaction, what happened? Okay, it going to reset the values. So what is the reset the value in the sense? Whatever the previous value is there, it going to make it as zero. Zero, 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 zero. Okay. So next, in first pulse, what happened? I'm going to provide it. Suppose the data 101. Okay, this is my data. This data I'm going to store in this register. Okay, let's see how it's going to store that. This is a okay, how I'm going to fit here in the sense. Uh, okay, in this order, MSP to LSP. I'm going to feed the data in the flip flop from uh, okay, let's see. This is my input. This is my input data 1011. Okay, how I'm going to feed the data in the flip flop in the sense from in this order I'm going to feed the data. In this order I'm going to feed the data. Okay, this is NSP. Okay, this is NSP. Okay, first I'm taking the first LSB bit. Okay, so what happened? This is a shift register. What happened? So this here, this data is a forward to here, forward to here. Okay, okay. Suppose okay, in the first clock cycle, I will show you what's the. Suppose if we consider the clock cycle end, happen. For example, your so what is the okay here what happened? So your input data, okay, your input data is accepted by D3, and the next. So what is the input for D2? The D2, what is the input for D2 in the sense? Q3 output is input for D2. Similarly, what is the input for input is nothing input for D1. Next one, what is input for D0 is Q1. Q1. Okay. Okay. This is a status. The same thing is represented here. Okay. Next, what happen? I'm going to First, the next class we take the next data. So what is the next data? 1. Okay, what happened? This is a 1. Okay, next clock cycle what happened? Okay, this data forward here, this one is forward here, this one is forward here. This is a 1, this is a 0, this is a 0. So here, similarly, the next data is 0. Okay, what happened? This is 0, 1, 1, one is forward here, this one is forward here. So what about now? What is the fourth one? I am providing the last value that is called as a 1. So what happened? 1, this is forward here, this is forward here, this is forward here. 0, 1, 1. So in the fourth clock cycle end, the fourth clock cycle end, clock pulse end, okay, we can complete operation and store the data successfully. We can take parallel. Is available. What happens? Okay, what is the output of Q1? Q3 is 1. So what is the output of Q2? The Q2 is 0. So when the data is available in the flip flop itself, I can able there is no extra clock cycle. Okay, that is a objective of serial in and parallel out. Okay, it's okay for you. It's okay for you.
Yes, sir.
Okay.
Okay.
So next time. We have seen serial in and serial out. In order to complete it's needed 7 clock cycle. 7 clock cycle. Okay. If we consider serial in and parallel, in order to complete the entire operation, 4 clock cycle it's enough. Okay, 4 clocks. Okay, this is one. The next. So what is the application of? The application of. Okay, the application of serial in and parallel. What is the application of serial in and parallel? Okay, where sense in the telecommunication. For example, if you had the broadband connection in your home, in the sense, for example, if you information, it's analog signal. The modem what happened? We have digital data. Okay, if you consider telephone line, the telephone line information is called as an analog signal. Okay, analog signal. How it going to transfer to the modem in the sense in the serial order, serial data, it accepts the data in serial order. And then after converting the digital data, what happened? It parallelly will send the data to the computer. So in order to browse the internet, okay, what happened? The modem, what happened? The parallel. Okay, this is one of serial and parallel. Okay. Okay, next thing is next concept is parallel in next receptor register is called as parallel in parallel out. Parallel in and parallel out. Receptor register parallel in and parallel. The name itself you can easily understand. So what is the meaning is parallelly you are going to provide input for the all the flip flop. So assume that it is a 4-bit register. 3 and D0. Parallelly it will generate the output Q3, Q2. Is in order to operate flip flop, we needed positive edge trigger or in both condition it goes to it's working properly. So for in this example, what happened? I'm going to consider negative edge trigger because bubble is there. So bubble in the sense it is called as a negative edge trigger. Okay, what is the meaning of what is the concept? Parallel. Suppose you have the data uh, one one in the sense how this. So our purpose what happened? I got to labeling the bits. This is called as I0. This is I1. This is I2. And this is I3. Okay, how we are going to provide the data? 3. Okay, this one is called as I2. Okay, this one is called as I1. Okay, and this one is called as I0. Okay, parallel out. When the data is available in the flip flop, that moment itself, it generate the out. Generate the out. Generate the out. Here Q2, this is Q0. Okay, okay. I will take one clock pulse. I will show you how it going to store the data and how we are going to take it out the data from the flip flop. Okay, so first I will show you before providing the clock pulse. What is the initial state? Initially, okay, okay. How you in the in block you are going to put parallel I2, I1, I0. Initially, what happened? 0. Okay. So initially, you are not providing any data. Okay. Initially, you are not providing any data. So what is the status of the flip flop? 0. So why are 0? Before start the initial, before providing the clock signal to the operation, the previous value. So now what happened? I'm going to provide the first clock pulse. Once provide the clock pulse, what happened? This is the information 1 1 0 0. This is the information I want to store into the flip flop. How do you providing it? 1, okay, okay, 0. Such a way information 1 0. So one the flip flop gets the clock cycle, what happened? That moment itself, what happened? It will store all the data, and parallelly, what happened? We can take it out the data in parallel. That moment itself, what happened? I will take it out the data from the flip flop. Okay. So in order to store the data in the flip flop, it's secure single clock cycle alone. Single clock cycle it's enough. Single clock cycle is enough to store 4-bit information. Okay. Okay. This parallel out, otherwise called as a this parallel out, otherwise called as a storage register, storage storage register or buff. This is a name parallel. So you have studied register. All the general purpose register based on parallel. Once you provide the data, that moment itself, you can take it out the data from the flip-flop. Okay, that is one of the application. Okay, what is the application in the sense? The computer organization has studied a general purpose register. He has studied memory address register. So all of them are memory address register and general purpose register. So all the registers based on parallelly and parallel out concept. Okay. Any queries? Do you have any?
No, sir.
Sir, next register is called as a parallel in serial out. Parallel in and okay. Serial out. Set register. Okay. Here what happened? It's going to perform two. Load the data. It will load the data parallelly, and second operation is and shifting the data, shifting the data in serially. But at a time, at a time, only one operation is going to carry on. One operation is carry on at a time. It's going to perform two loading and in particular clock moment, it's going to carry on only one operation at a time. In particular clock cycle, only one operation is going to carry on. Okay, how we are going to implement that operation means make use of multiplexer. So implement. Okay, I want to, for example, I am providing the transfers in the sense either setting operation. It's going to perform only one operation at a time. How we are going to implement means implement using multiplexer. Okay, what is a multiplexer? Okay, we are going to implement that operation using multiplexer. Okay. Now the control signals are the multiplexer. Here to move on to that concept, I will provide the specification of parallel in and serial out. Okay, what is the meaning? Parallel accept the data from the user and then shifting it performs shifting operation. Serial is it going to perform shifting operation. It is called as a serial out. Serial out. This is called as a parallel in. So already I said at a time what happened, it's going to perform only one operation. So in order to performing operation, we needed a clock pulse. Already I said in order to control the control signal name we call it as shift load bar signal. The control signal name is called as a shift load control signal. Shift load control signal. Okay. Suppose the shift. Suppose I am a user as I okay. Suppose I am providing input as a 0. What happened? The shift value equal to 0 and load. What is the load? Load complement. So 0 bar is nothing but 1. What is the meaning is it So it accepts the data parallelly from the user. Parallel data will be loaded into the register. Parallel data loaded into the register to register. Suppose I'm a user, I'm providing input as 1. I'm providing input the shift value equal to 1, shift value equal to 1, and load bar value equal to 0. So what happened? It's going to perform shift operation. So load bar value equal to 0. So what happened? It's going to perform data will be shifted towards right side direction. So data will be shifted towards right side direction. Right side. Okay. Okay. It's okay for you. So we are using control signal that is called as a shift comma load. Suppose we are going to provide input as a 0 value equal to 0 in the, it accepts from the user. Suppose 1 in the sense it's shifting the data towards right side direction. Okay, in order to implement that control signal, multiplexer. Okay, this is a load. Here providing the shift. This is the input for multiplexer. Okay, this is a multiplexer 2 by 1. Okay, what is the meaning is 2 bit is input and produce a single control signals are available. Okay, what are the control signal in the sense? Either shift or load. Either shift or load bar. Load bar. Okay, previously we have seen S equal to 0, what happens, sir? S equal to 0 means I'm providing input as a 0, what happens? Load bar value equal to 1. Load bar value equal to 1. Suppose S equal to 1. S equal to 1 in the sense the shift value equal to shift value. Based on the Boolean expression, I'm going to write the Boolean expression for a multiplexer. Suppose my input is 0, that can be represented as a complement. S is nothing but input. Complement means suppose I'm providing input as a 0 means, so what happen in the sense it will load the data from the user. It accepts the data from the user. Suppose I'm providing input is 1. 1 in the sense it performs shift operation. It performs shift operation. Okay, this is a expression for Boolean expression for multiplexer. Same thing I'm going to implement it using gates. Okay, how do you implement that? How do you do that? Okay, this will be implemented using one gate. This is also we can implement using one gate. So what is the input for first AND gate? S bar. Second one is the low. What is the next one? S. What is the input for next one? Shift. Okay. Okay. So finally, here plus is there. Okay, how do you implement using OR gate? Okay, this is a way what happen. We can implement the multiplexer. So while I'm going to write the law to use this, you can easily this is acting as a multiplexer. Okay. Do you have any queries? Do you have any queries?
No, sir.
Okay. So next I'm going to write the logic diagram of parallelism and serial. Parallelism and serial. Okay. How do you draw that? Okay. First, the control signals are available. Okay. What is the next one? To control signal, either shift or load bar. Okay. Um, okay, this is a 4-bit register, so with the 4 flip long associated with the 4 flip flop. Okay, and then each one is accept the input and produce the output. D2, Q2, D1, Q1, D0, Q0. So in order to functioning the flip flop, it's needed either positive edge trigger or negative edge trigger. In this case, I'm going to provide positive edge trigger. So while designing the circuit, you can use any one of the edge trigger, either positive edge trigger or negative edge trigger. Okay, okay. The clocks. Okay, any one of the clocks. Okay, the both condition it can able to operate. Okay. Um, okay, the D3 what happened? It simply accept the data from the user. Okay, this is I3. Uh, okay, at a time I can able to perform only one operation. So in order to control the circuit, we are going to use multiplexer. Okay, already we have seen the circuit diagram for multiplexer. Okay, this is circuit diagram. So each flip flop, what happen? It associated with the multiplexer. Associated with the multiplexer. Associated with the multiplexer. Okay. Okay. Okay, this is treated as a 1, this is a 2, this is a 3, this is a 4, 3. Okay. 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 Suppose I am providing input as a 0. 0 in the sense what happened? The load signal is in input. Load signal is in input. So what is the meaning is it simply accept the data. Am I correct? So here what I'm going to do. So whenever suppose I'm providing input as a this is what happened. This is a load line, this is a shift line. The load line is enabled. So load line is enabled. So this is values of 1. So here what happened? It will simply accept the data. So all the flip-flop what happened? It going to accept the simply data. Already you know that the truth table of AND gate. So what is the AND gate of the truth table? 0 0 in the sense 0, 1 0 in the sense 0, 0 1 in the sense 0, 1 1 in the sense 0. So what is the meaning is, suppose I am taking function, based on the second input only, it going to decide the output. Am I correct? So here what happened? One of the input value equal to 1, another input is I2, another input is I2. So what is the output? Here I2. So what is the meaning is, it simply accepts the data from the user. Okay, I2. So what about this is already said this is called as a load line. This is called as a shift line. So whenever the s equal to 0, what is the value of shift? Shift equal to 0. Shift equal to okay 0. Suppose already you know that the AND gate any one of the input is 0. What happened? The output equal to 0. So this is the input for OR gate. The OR gate what happened? If any one of the input is 1 in the sense what happened? That is output. So what happens simply it generates the I2. This I2 is input for this this flip-flop. Same procedure for all the rest of the flip-flop. So one of the line is connected with the load, another line what happen, it will accept the data from the user. Three, similarly, one of the line is connected with the load signal, or another line is accept the data from the user. Okay. Okay. The next AND gate what happen, it's connected with the shift register. Okay. The output of the first D flip flop is the input for this AND. Same procedure for the rest of the case also. Okay. So this is connected with here. This is connected with here. Okay. So suppose S value equal to 0 in the sense what happens? The load this line is 1 and this line is equal to 0. So what happened? It will simply generate the input. This case is a 0. Suppose I'm going to take opposite case. Suppose S value equal to 1. If S value equal to 1, what happened? The line value equal to 0 and shift value equal to 1. So what happened? Uh, this is a 0. This line is 0. Here what happened? 1. So what happened? So it will take the previous state of the flip flop. This is the input. Okay. So it going to suppose Q3, the Q3, what is the functionality of AND gate? Already we have seen, if any one of the input is, both the inputs are 1, then only what happens? It's going to generate the output is 1. Suppose, if any one of the input is 1, the rest of the input is 0 in the sense, the output is depending on this second input combination. Similarly, here Q3, 1, what is the meaning is? Q3 is the input for, the Q3 is going to generate, okay, this is output. Here what happens? This is a 0, okay, another input is Q3 is as an output. So what is the meaning is, so based on that what happens, we are shifting the data from here to there. So this is where what happens, we are going to perform shifting operation. Okay, are you able to understand? Hello?
Yes, sir.
Okay, it's a time for next class. Tomorrow I will explain same concept once again. Okay. So now I'm going to take the attendance. Okay, thank you so much. We will meet in tomorrow. If you have any queries to be stay on online, otherwise you can end up the session. Thank you.